A bob is whirled in a horizontal plane, which is given here. So let us assume I have one object which is tied with a string and is moving in a circular motion with a string tied, right? So string provides necessary force to move in the circle, right? And that force is the centripetal force, and that centripetal force is balanced by the tension. So what is the equation for the centripetal force? So Fc is equals to, it is mv square by r, that we know, right? But we all know that v is equals to omega r. So instead of v square we can write omega square r square by r. So r and square will get cancelled. So equation for this will be m omega square r. This is the centripetal force, and this centripetal force is balanced by the tension, right? So we can say that the tension in the string will be T is equals to m omega square r. Now here what is given? The tension in the string is T. Now if the speed becomes 2 omega, right? The speed becomes 2 omega and we keep radius same. So in that case what will be the new tension? So here T dash will be, we are using this equation here, m. Now omega becomes 2 omega, right? So omega, new omega is become 2 omega, and if you are square it, then you will get 4 omega square. So 4 m as it is, m, then omega square and r. So if you compare with the first equation, it is 4 times of the first, means the tension will be, new tension will be 4 times of the original tension. Question number 2. A particle moving with uniform speed in a circular path maintains. So here what is given? See, whenever a particle is moving in a circular path, right, whenever it is moving in a circular path, at each point its speed, let us assume it is moving in an anti-clockwise manner. So at each point its speed is directed along these arrows, right? So its velocity changes, whereas the magnitude of the velocity remains constant, that is the speed remains same. So we can say that and whenever the direction of the speed changes, we can say velocity changes, because velocity is a vector quantity, hence velocity is varying, and also the acceleration is also varying, because at all point if you check the velocity, right, then the velocity will be different, not the magnitude of the velocity, right? But if you check, right, let us assume the object is here, right, and when it comes here, in that case the change in velocity will be root 2 v, right? But when the object is here and comes here, right, at this point the change in velocity will be minus 2 v or 2 v, right? So the velocity changes, as the velocity is not changing uniformly, right? That's why the acceleration is varying. Whenever we can say constant acceleration, whenever the velocity is changing at uniform rate, but here velocity is not changing at uniform rate, and hence we can say that the varying velocity, the motion is varying velocity with varying acceleration. Question number 3. A logic circuit provides the output y as per the following truth table. So we have to find out that the expression for this given truth table, right? Now you can clearly see for all the terms in B, right, the output is like B bar. It means if here it is 0, you can see output is 1. When it is 1, here it is 0. When it is 0, here it is 1. And when it is 1 here, the output is 0, means clearly the output is of reverse of B every time. It means we can write this equation for the given truth table. So y is equals to B bar. So option number 3 is correct. Question number 4. In the above diagram, a strong bar magnet is moving towards solenoid 2 from solenoid 1. The direction of the induced current in solenoid 1 and that in solenoid 2 respectively. So here you can see here we have two solenoid. This is solenoid 1, this is solenoid 2, and a bar magnet is moving from solenoid 1 to solenoid 2. Then in that case we have to identify the direction of the induced current in both the solenoid. Remember, whenever this magnet is going away from the loop, the magnetic field decreases, So this loop will try to maintain the magnetic field, so it will try to attract this one, right? So whenever the magnetic field is going away, or whenever the magnet is going away, the loop will try to bring it back, and whenever the magnet is going towards the loop will try to stop it or oppose it. That is, the loop doesn't like change in magnetic flux. That's why, right? This you will learn in, maybe you have learned in electromagnetic inductions. So for the first loop, what you can see here is the north pole is going away from the first loop. So as the north pole is going away from the first loop, to attract this north pole, it will create a south pole. Now what will be the direction of current to create a south pole? That we can learn from this right hand grip rule, right, or Maxwell's grip rule. So if you hold the this solenoid with your right hand like this, right, and such that the curl of your fingers point in the direction of the current, then the direction in which the thumb is pointing is north and the other is south. Okay, so for the first case here, the north pole is going away and you need to create a south pole here. So what should be the direction of the current? So here you can see I have held this solenoid such that this thumb of right hand is pointing towards left, because I want south pole here. So the direction of the current will be upward on the side which we are observing right now, right? It is a very easy explanation. Okay, so here I have labeled the direction of the current. So here the current is going from A, right, then here it is going on the other side, again coming back, right, going other side. Similarly here the current is coming from actually A, going towards other side, and then from the other side is coming out of this point B. So the direction of the induced current in solenoid 1 is from A to B. And if we try to think about the second solenoid, then what is happening in the second solenoid? The south pole is coming towards it, right? So the loop will try to oppose that change in flux by creating a south pole here. Now to create a south pole here, the direction of the current should be here clockwise, and on the other side it should be anti-clockwise. So for that one here, you can see here, in that case if I want to create a south pole this side, then in that case I have to hold my fingers, hold this solenoid such a way that the right hand, the thumb of right hand is pointing towards this side, right, such that the right side north will generate and towards left side the south pole will generate, and for that the direction of the current will be downward on the side which facing towards us. So the direction of the current will be like this. Okay, so in that case the current is, see here, it is coming through the D, right, and going on the other side, then from here on the front side again going other side, then again coming out on the front side, then going other side, coming on the front side, and similarly it will enter the C point here. It means the direction of current is from D to C. So which option is from A, B and D, C? It is A to B and D to C. So option number 1 is the correct answer. Question number 5. Given below two statements, one is labeled assertion and the other is labeled reason. So the potential V at any axial point at 2 meter distance from the center of the dipole of dipole moment P of magnitude. So dipole moment is given and potential, that is voltage, is given, and let us verify that the given voltage is right or wrong. So for dipole, the general equation according to our textbook is V is equals to wait a minute, V is equals to Kp by R square. This is the equation for the potential due to a dipole, and this is the equation which are given in the other book, right? So here K we can write 9 into 10 raised to 9, P which is given here and so P is given and R is the distance. So if you have a dipole, this is and this is negative, so from the center at distance 2 meter, the electric potential that we have obtained by using this equation is 9000 volt. So same here, it is given 9000 volt. So the assertion is correct. Now reason, V is equals to 2P. So if you rewrite this, you will get 2kp by r square. So this is a wrong equation. This kind of equation is not there anywhere for this electric potential. So statement 1 is true and statement 2 is false. So the correct answer is which one? A is true, R is false. So C is the correct one. Question number 6. Match list 1 with list 2. See here in this question some magnetic properties are given and we have to match their properties with the right side. So if you try to check this first, let's say we are very familiar with non-magnetic. Non-magnetic means that doesn't have any susceptibility. So 1. So D correspond to 1. Then paramagnetic or let's say ferromagnetic. So ferromagnetic have the highest susceptibility. So B correspond to 3. Now see, if we know any 2, then we can find out the other. So where D1, so in this and this 1 and 4, D is 1. Then for B, here you can see 3 and here also B 3. So 1 and 4, again there is a match between 1 and 4, right? Now paramagnetic, so paramagnetic has a very small susceptibility. So for C there is option number 4. So C there is option number 4. So C option number 4. So this is the option which correctly match the data. So option number 1 is correct. Question number 7. In a uniform magnetic field of 0.049 Tesla, a magnetic needle performs 20 complete oscillations in 5 seconds. So oscillations and time is given, so we can find out frequency. So frequency will be here, it is 20 number of oscillations. So 20 by 5, it is 4 Hertz. Then it is given the moment of inertia of the needle. So again moment of inertia is also given. If the magnitude of the magnetic moment is x into 10 raised to minus 5, then the value of x is. So here frequency it is there. Now see, whenever it is asked the magnetic moment, then oscillation, both are connected. So there is one equation in our textbook which is T is equals to 2 pi under root I by mb. So this equation perfectly match with the given data, right? So here I is the moment of inertia, I is moment of inertia, and how much it is given? 9.8 into 10 raised to minus 6. Again magnetic field is also given. How much magnetic field is given? It is 49 into 10 raised to minus 3 Tesla. And time period T, now when we know frequency, right, which is 20 oscillations by 5 seconds, so it is 4 Hertz. So the time period will be 1 by 4 seconds, and that is 0.25 seconds. So we have all the data. Now we can use this equation directly, put all the data, and we can obtain the value of magnetic dipole moment m. So I am squaring on both the sides. So here it is t square, then here 2 pi is 4, 2 pi square is 4 pi square, then I by mb. Make m as a subject. So what you will get? If you make m as a subject, then it is I, then 4 pi square, t will be here, so it is t square mb. Now I have put all the data in this expression here. So the value of moment of inertia is 9.8 into 10 raised to minus 6, then 4 pi square, the answer is in pi square, so we will not remove pi square. Then the time period here is 1 by 4 seconds, so 1 by 4 square, and B magnetic field is 49 into 10 raised to minus 3. So if you solve all this, you will get answer, which is, I have solved here, it is 1280 into 10 raised to minus 5 ampere meter square. So our correct answer is 1280 pi square, that is option number 4. Question number 8, which is a very easy question. In an ideal transformer, the turn ratio NP by NS is 1:2. The ratio Vs to Vp means EMF or voltage in secondary to the voltage in primary. So we know this very famous relation from the chapter 7, class 12. It is NP by NS, that is number of turns in primary coil by secondary coil, is equals to voltage in primary coil by voltage in secondary coil, is equals to Is by Ip, current in secondary by current in primary. So here number of turns and voltage needs to be related. So here NP by NS is given 1/2, which is directly equal to Vp by Vs. So again this will be equal to 1/2, but it is asked Vs by Vp. So what we will do? We will reverse it. So it becomes 2:1. So option number 2 is correct answer. Next, question number 9. In a vernier caliper, n+1 divisions of vernier scale coincide with n divisions of main scale. So as per the given data, n+1 VSD means n+1 vernier division coincide with n divisions of main scale. So then what will be the value of one vernier scale division? So one vernier, so if just take this towards right side, you will get one vernier scale division will be n by n+1 of the main scale division. Now to find least count, see here it is given vernier constant. So vernier constant means least count. So to find least count, what is the equation? Least count is equals to, it is 1 main scale reading minus 1 or minus the vernier scale reading or vernier scale division. So 1 MSD minus, what is the value of vernier scale division in terms of MSD, not Mahendra Singh Dhoni, it is main scale division. So 1 VSD is equals to n by n+1 MSD. So here it is n by n+1 MSD. This is a very easy question, right? Now if you take this 1 MSD common, it is 1 minus n by n+1. Now 1 MSD, it is given 0.1 mm. 0.1 mm means it is 1 by 100 centimeter. So it is 1 by 100, here it is centimeter. Okay, and if you solve this, it is n+1 minus n by n+1. So it is 1 by n+1. So LC here it is 100 and 1 by 100, and it is 1 by n+1. So it's a very easy question. Moving to the next question. Question number 10. A horizontal force 10 Newton is applied to a block A as shown in figure. The mass of blocks A and B 2 kg and 3 kg respectively. The blocks slide over a frictionless surface. The force exerted by block A on block B is. So very easy question, right, based on contact force. So here what is happening, as both are on a smooth surface and they are moving with common acceleration, so we can assume 2 plus 3, it is a 5 kg block on which a 10 Newton force is acting. So what will be the acceleration? It is A is equals to F by m. So net force is 10 Newton and mass of combined mass is 5. So they move with a common acceleration of 2 meter per second square. That is, when you apply a 10 Newton force to the first one, right, it will accelerate and it will also produce acceleration in the second one. Now to produce acceleration of 2 meter per second square on the second block, the first block must apply some force on the second block, right, which is equal and opposite. So this is called a contact force. Okay, so if we just try to assume the second block, just focus on the second block, draw a free body diagram. So on the second block, N force, there is a normal or we can say contact force is acting on it, which is driving it with an acceleration of 2 meter per second square. So from the Newton's second law, force is equals to mass into acceleration. So mass of the second block is 3 acceleration is 2, means the 6 Newton force is acting on the second block and this force is provided by the first block. Okay, so the force exerted by the first block, block A on block B, is 6 Newton. Again, it was a very easy question. Moving to the next, question number 11. If x is equals to phi sine pi t plus pi by 3 represent the motion of a particle executing SHM, the amplitude and the time period of motion respectively. So again, it's a very simple question. What we will do, we will compare this with the general equation of SHM, which is x is equals to a sine omega t plus phi. So if you compare this, then a becomes 5 here, so amplitude is 5 meter, and if you compare this coefficient of t here, so omega, and here coefficient of t is pi, so omega is equals to pi, and in general we can write omega is equals to 2 pi by t, but here omega is pi, so pi cancel, so t is equals to 2 seconds. So our correct option is option number 2, 5 meter 2 seconds. Question number 12. A terminal voltage of a battery whose EMF is 10 volt and internal resistance is 1 ohm, when connected through an external resistance of 4 ohm as shown in figure, we have to find the terminal voltage, right? Here it is asked the terminal voltage of the battery. What is terminal voltage? The terminal voltage is the voltage developed across the external resistance which is connected to the battery having some internal resistance, right, which is given in the figure, so no need to draw. So in general, the total EMF, the expression for the total EMF is equals to V plus I into R. So this is the voltage drop which is called the terminal voltage, and this is the voltage drop across the internal resistance. So I am taking I as common, right, because V is equals to, here you can write V is equals to I into R. So here IR plus I into small r, so I common R plus R. So the current, this is actually a general equation, right, but someone fails to remember this equation, then you can derive like this. So the current will be total EMF by total resistance R plus R. So the total EMF is 10 and the total resistance is 4 plus 1 5 volts. So the total current drawn from the battery will be a 2 ampere. Then how much voltage will drop across this 4 ohm resistance? So the voltage drop will be I into R. So the current passed through the resistor will be 2 ampere and the resistance of this is 4. So it is 2 into 4 will be 8 volt. So terminal potential will be 8 volt. Question number 13. Given below are two statements. Statement 1, atoms are electrically neutral as they contain equal number of positive and negative charges. Yes, it is correct. All atoms are electrically neutral. Statement 2, atoms of each element are stable. No, from here it is incorrect. See, if you see the atoms of the higher order or the atoms of very lower order, right, then these atoms are not stable. If you check it by at the nuclear level or at the chemical level, then all these, like sodium, if you check it at the atomic level, right, then sodium is very unstable. It may blast, right, when it comes in contact with water. And similarly, if you check at the nuclear level, then the uranium, right, and the other materials, radioactive materials, are not stable. Means all atoms are not stable. Okay, so statement 2 is incorrect because here it is given that they are stable. So statement 1 is correct and 2 is incorrect. So option number 3 is the correct choice. Question number 14. If c is the velocity of light in free space, the correct statement about photon among the following. So option number A, energy of the photon, right, we know that the energy of photon E is equals to h into nu or h into f. The velocity of the photon, right, when it is in vacuum it moves with speed c. The momentum of photon, to verify that I have written here from de Broglie's equation, lambda is equals to h by p. So p is equals to h by lambda. Now lambda you can write c by f or c by nu. So here if you place c by nu, then the nu will go up, so it is h nu by c. Okay, so here it is again a correct statement. So A, B, C are correct. Checking the fourth one, in a photon electron collision both total energy and total momentum are conserved. Yes, in dual nature it is given that, right, energy and momentum both are conserved. So statement A, B, C, D are correct. Now let's check E. Photon possess positive charge. No, it is wrong. Photon is totally neutral, right? So option number 2 is the right choice. Question number 15. We have to match list 1 with list 2, and here you can see which is a, see, this I have solved just in 5 seconds because this question is very easy. Here you can see all the transitions are taking place to the second level, that is the final level is the second level, and whenever the transition are taking that is, if all the transition the final level is same, in that case remember this one, for same final energy level longer transition means shorter wavelength. Why? Because longer transition means more amount of energy will be released, because the electron is coming to the lower level, So when it is coming from a very higher level to a lower level, then in that case more amount of energy will be released from that one. Okay, and more amount of energy means higher frequency means shorter wavelength. So for this transition which is correspond to 6 to 2, right, 6th level to 2nd level, the wavelength should be shorter. From all this, which has the shortest wavelength? So the shortest wavelength is this one, 410. So if you see here, the second one, A is A has third, but here D, we need to check for the D, right, and D should be 1. So in which one D is 1? So in option number 2 you can see D belongs to 1. Now to verify this, check out the shortest transition, right. So shortest transition is 3 to 1. In the given transition, the shortest transition is from 3 to 1, right, and 3 to 1 correspond to the longest wavelength, right. It's a vice versa, shortest transition longer wavelength, longer transition shorter wavelength. So this is a shorter transition, so longer wavelength will be 656. So A correspond to 3. So A correspond to 3. So option number 2 is correct. Question number 16. A tightly wound 100 turns coil of radius 10 cm carries a current of 7 ampere. The magnitude of the magnetic field at the center of the coil is. So for a coil, B is equals to mu naught I by 2R, where R is the radius, and if the coil has n turns, then we can multiply it by n. So just put all the data. Mu naught is 4 pi into 10 raised to minus 7, current is 7 ampere, number of turns is 100, and the radius is 10 centimeter, right. So 1 centimeter 10 centimeter, I can write 10 centimeter is equals to 10 raised to minus 1. So here it is 2R, so it is 2 into 10 raised to minus 1. If you solve this, you will get 44 into 10 raised to minus 4, and that is nothing but 4.4 milli Tesla. So the correct answer, the correct option is option number 3. Question number 17. The output Y of the given logic gate is similar to the output of A. Now here some mixed gate are given, and from this mixed gate we have to identify that this gate behave as which type of gate. So here what you can see is, see here these are short circuit, right, means whatever you give here it will come on the other side, and it is actually a shorted NAND gate, right, and which behaves as a NOT gate, right. You should learn theory properly, then you will identify that this behave as a NOT gate. Again this behave as a NOT gate, right. Why? Because here you can see here this inverter is also put. So if you give here A, the output will be A bar. If you give here B, the output will be B bar. Now here it is here you will find A bar, and here you will find B bar, and this behave as a NOR gate. Why NOR gate? it's actually a OR with a round here, means it behave as a NOR gate. So for OR gate, if you have OR gate, then it is A plus B, here A bar plus B bar, but this is a NOR gate, not OR gate, right, means it will again get inverted. So we can put again bar on this, the final expression. So the output will be A bar plus B bar, the whole bar, right. Now very easy trick, break the bar, change the sign. So I have break this bar and I have changed sign from plus to dot. So A double bar becomes A and B double bar becomes B. So A dot B is similar to a AND gate. So this behave as AND gate. Question number 18. A wire of length L and resistance 100 ohm is divided into 10 equal parts, right. So we know that the R is equals to rho L by A. So R is proportional to length. So if you divide it into 10 equal parts, then each part will have resistance of 10 ohm, right, because it is given that the resistance of the whole wire is 100. If you divide it into 10 equal parts, then the resistance of each part, will be here, it will be 10 ohm. Now it is given that the first 5 parts are connected in series. So when you connect 5 parts in series, then the total resistance will be 50, because 10 plus 10 plus 10, 5 times. So it becomes 50. And the next 5 parts are connected in parallel. So for parallel combination, the resistance of the one divided by the number of resistors connected in parallel. So each has 10 ohm, each wire is of 10 ohm and there are 5 resistors. So it will become 2 ohm. So now this circuit, right, 5 resistors which were connected in series having total value 50 ohm and 5 resistors which were connected in parallel whose total value become 2 ohm are connected in series, that is they are connected back to back. So the total resistance will be 50 plus 2, again it is a series combination, right. So it becomes 52 ohm. Question number 19, again it is a very interesting question. In the nuclear emission stated above the mass number and the atomic number of the product. So see, initially we have this nucleus whose mass number is 290 and atomic number is 82, and there is a alpha decay process, alpha particle is coming out from it. So when alpha particle is coming out from it, the alpha particle is like a helium nucleus whose mass is 4 and atomic number is 2. So when it is coming out, so the mass number decreases by 4 and the atomic number decreases by 2. Okay, so the new mass number will be 290 minus 4 will become 286 and new atomic number will be 82 minus 2 is 80. Now in the second process, a positron is coming out. Whenever positron is coming out, it means a proton decays into neutron and a positron. So the positron will coming out from the nucleus, whereas the neutron will reside into it. Means here the number of protons decreases and number of neutron increases, but the total number of proton and neutron, that is the number of nucleon, will remain same. So it becomes 286 as it is, but a proton is converted into neutron, right. So number of proton decreases by 1. So new atomic number will be 79. In the second process, a neutron is decaying into a proton and an electron, right, that is a beta minus decay. So the electron will come out from the nucleus, whereas this beta whereas the proton will reside into it. Okay, so here a neutron convert itself into a proton. So when number of proton increases, number of neutron decreases, but the mass number remain same. So as number of proton increases, the mass number will increase by 1. So it is 79 plus 1, it becomes 80. In the final process, again electron is coming out. When electron is coming out, right, it is also known as beta minus particle. So whenever the electron is coming out, it means a neutron converts itself into a proton. So again, what is happening? The mass number remains same, but the atomic number increases by 1. So it is 80 plus 1 becomes 81. So the correct option is option number 4, 286, and atomic number is 81. Question number 20. The maximum elongation of a steel of 1 meter length if the elastic limit of the steel and its Young's modulus respectively are 8 into 10 raised to 8 Newton per meter square and Young's modulus is given 2 into 10 raised to 11 Newton per meter square. So what is given here? Length is given, the elastic strength or elastic limit is given, Young's modulus is given, and we know this equation y is equals to F by A delta L by delta L, and it is asked to find delta L. So if you make delta L as a subject, then in that case delta L will be F by A, L by Y. So F by A which is given 8 into 10 raised to 8, length is given 1 meter and Young's modulus is given 2 into 10 raised to 11. If you solve it, you will get 4 mm. So the correct answer is answer number 1. Question number 22. If the monochromatic source in Young's double slit experiment is replaced by a white light, then see, monochromatic means single wavelength. So let us assume if you have a red light, then you will observe red and dark fringes, right? If you have yellow light, you will observe yellow, then no fringe means dark, then yellow, then dark, then yellow, right? So alternate yellow and dark fringes observed. But what if you have white light? Then if you have white light, then when the lights are coming out, when the light is coming out from this slit, all this light suffers different diffraction, or they bend at different angles, they diverge at different angles, okay, but all the light which reaching at the central point will have same path difference. All the light which is coming here, they will have same path difference because they travel same distance. So their path difference will be 0. But suppose a light which is coming from this point which is reaches here, and a light coming from this point which is reaches here, so their path difference, there will be a path difference, okay. So as there is no path difference between any wavelength at the central point, hence there will be a very bright spot, okay. So there will be a central bright spot, but what about the other part? So other part will be surrounded by the colored fringes. Why colored fringes? Because all the light bends at different angle due to their wavelength, right? Due to their wavelength, they bends at different angles. So they will produce color fringes according to their wavelength. Because see, if you have that, if you remember this equation, beta is equals to lambda d by d, means the width of the fringe is proportional to lambda, means the width of the red light, red fringe will be more compared to that of the violet. Hence at the end you will observe red, and at the center you will observe white, and in between here you will observe, right, that is a blue or a violet. Hence the correct option is there will be a central bright fringe, white, surrounded by a few colored fringes. Question number 22. At any instant of time, the displacement of any particle is given by 2t minus 1 under the influence of force of 5 Newton. The value of instantaneous power is, see, whenever force and powers are related, we can relate like this: force is equals to, power is equals to force into velocity. Now force is given 5 and displacement is given. So whenever displacement is given, if you differentiate it, you will get velocity. So if you differentiate this term, you will get velocity is 2 meter per second. So for the power will be force into velocity, 5 into 2 is 10 watt. Question number 23. Consider the following statements A and B. So for a solar cell, IV characteristics lies in the 4th quadrant. So here the IV characteristics of solar cell is given here, you can see, which is as per the textbook. Okay, we are not going into the depth, okay, but you can see this is the IV characteristics of the solar cell, and here it has occupied 4th quadrant. So A is correct. Now in the second part, in a reverse bias PN junction diode, the current measured in microampere is due to majority. No, in the reverse bias junction, the current is due to minority charge carriers, right, not due to the majority charge carriers, and statement 2 is incorrect. So option number A is correct. Question number 24. Two bodies A and B of same mass undergo completely inelastic one-dimensional collision. Whenever the word given completely inelastic means bodies will stick together, okay, then it is given the body A moves with velocity v1 while the body B is at rest. So in the initial situation, body A is moving with v1 velocity and B is at rest, and after collision they move with a velocity which is given here v2. So from the conservation of linear momentum, initial momentum of the system is m1 v1, final momentum they stick together, right. So their combined mass will be m1 plus m2, their combined mass will be m1 plus m2. Now as all three are, as both are identical, so here m initial speed is v1 and this m plus m is 2m and the final speed is v2, m and m will get cancelled. So the ratio v1 by v2 will become 2:1. So option number 2 is correct. Question number 25. A light ray enters through a right angle prism at point P with the angle of incidence 30 as shown in figure. It travels through the prism parallel to its base BC and emerges along the face AC. The refractive index of the prism is. So first let us try to analyze this figure. So here a light is entering, here light is entering at an angle 30 which is labeled here, okay, then it enters here and the light goes like this and it moves parallel to the surface. So when the light moves parallel to the surface, the angle of emergence is 90 degree, right, the emergent angle is 90 degree, and also in the given question this angle is 90. So here A is 90, and we know that whenever the light moves parallel to the surface, means whenever the R is 90 for these two surface, this is angle of refraction, means the incident angle is nothing but a critical angle. So here R2 angle is critical angle, and for critical angle we can write sin IC is equals to 1 by refractive index. The same fact we are using here. So from figure I is equals to 30, A is 90, emergent is 90, and R2 is our angle of R2 is critical angle. Now from the theory we know that R1 plus R2 is equals to angle of prism. So if you make R1 as a subject, you will get A minus R2, where A is 90 and R2 is critical angle, so it is 90 minus IC. Now what we are doing, we are applying Snell's law to this first surface, that is surface AB. So Snell's law is N1 sin theta 1 equals to N2 sin theta 2. So N1 it's air, so for air we are writing 1 and angle of incidence is 30, so sin 30 is 1 by 2, N is the refractive index of the prism, and sin R1, right. Now what is R1? Sin R1 is this angle right here. So R1 is nothing but 90 minus IC. So 90 minus IC or 90 minus R2, any of the two you can put. So 1 by 2 is equals to N, 90 minus theta is cos theta. Now cos theta is equals to under root 1 minus sin square theta, we are using that, okay, and again we are squaring on both the sides. So 1 by 2 is 1 by 4 and become n square, and this is 1 minus sin square theta. Now almost we are done with this solution. Now what we are doing is sin square theta is nothing is 1 by eta. Sin theta is 1 by eta, because here sin IC is R2 is a critical angle. R2 is a critical angle, and for that critical angle we can write sin IC is equals to 1 by eta. So here sin square R2 is 1 by n2 square, 1 by n square or eta square, whatever you can write. Now multiply this inside, it becomes n square minus 1 equals to 1 by 4. Just rearrange, you will get refractive index is equals to root 5 by 2. Question number 26. The graph which shows variation of 1 by lambda square and its kinetic energy. So which one is the correct option? Now we know that the kinetic energy is given by K is equals to P square by 2m, and from de Broglie's equation lambda is equals to h by P. So if you make P as a subject, it become h by lambda. Just put this value of P here. So this become h square lambda square by 4m. Okay, wait, there is a mistake, let me correct it. Okay, so if you just what we are doing here, K, here it is P square, so P square becomes h square, then it becomes lambda square 2m, right? Here there is no 4, okay, it's 2m. So here K is equals to h square lambda square. So simply we can say that K is proportional to 1 upon lambda square. So if you draw the graph between K and K is the kinetic energy. So if you draw the graph between K and lambda square, then you will get graph number 2, right? But here the graph is given between K and 1 upon lambda square. So we can write K is equals to some constant into 1 upon lambda square. So K by 1 upon lambda square is constant, right? So the this graph is given by graph number 4, which is the correct relationship. Okay, suppose if the graph is asked between energy and lambda or lambda square, in that case you may go with the second graph, right? But here it is 1 upon lambda square. So K and 1 upon lambda square are directly related, okay, and hence the graph number 4 is the right choice. Question number 27. The quantities which have same dimensions as those of solid angles. So solid angle, right? So here you can see stress. If you go with the second question, second option, stress has a dimension Newton per meter square. So which is totally incorrect, because the solid angle doesn't have any dimension. Solid angle doesn't have any dimension. Okay. Similarly strain and arc. So strain doesn't have dimension, but arc has, because arc has length. Again angular speed and stress has dimension. So here the term number 1, strain and angle, are the quantity which are dimensionless, same as the solid angle, because solid angle also doesn't have any dimension. Question number 28. An unpolarized light beam strikes a glass surface at Brewster's angle. Then what will happen when a light strikes at a surface such that the angle is a Brewster's angle? So at Brewster's angle, the reflected ray is totally polarized, whereas the refracted ray is partially polarized, and the Brewster's angle is when the angle between the reflected ray and the refracted ray is 90 degree. At that time the incidence angle is called, the angle of incidence is called Brewster's angle, right? This is from the theory. So the reflected ray will be completely polarized, but the refracted ray will be partially polarized. So option number 4 is the right choice. Question number 29. The moment of inertia of a thin rod about an axis passing through its midpoint and perpendicular to the rod is 2400 gram per centimeter square. The length of the 400 gram rod is nearly, so here length is asked. Now for a rod, the moment of inertia about an axis passing through its center, geometrical center, is given by ml square by 12. Now L we have to find, so we make L square as a subject, so it is 12 into I by m. Now 12, the moment of inertia is given 1200, we are not converting into SI, we are just keeping it in CGS, and the mass is given 400 gram. So if you solve this, right, you will get L square is equals to 72. So L is equals to root 72. Now root 72 is very near to 8.5 centimeter, because everything we have kept in CGS. That's why answer is in centimeter. Question number 30. A thin flat circular disc of radius 4.5 cm is placed gently over the surface of water. If surface tension of water is 0.07, then excess force required to take it away from the surface. So if a disc is placed on a surface and you want to lift it, and if the surface is water or any liquid, right, then in that case the surface tension will try to pull it, because due to surface tension this disc will stick to the surface. So the total force you need to apply is its weight plus the force due to surface tension, right. So it is asked excess force, so that excess force is nothing but the surface tension. So excess force due to the surface tension is equals to surface tension into length of this disc. Okay, now sometimes the surface tension is denoted by T or it is denoted by letter sigma. So here we denote it by letter T. So T, and the length, the circular, this length is 2 pi r. So surface tension is 0.07, which is given to the value of pi I have taken is 22 by 7, and the radius is 4.5 centimeter, which you can write as 45 by 1000. If you solve it, you will get 19.8 millinewton, and which is very near to this one, option number 1. Question number 31. A thermodynamic system is taken through the cycle A, B, C, D, A. The work done by the gas along the path B, C. So here B to C, you can see here this x-axis gives volume. So along the path B to C, the change in volume is 0. So work done is given by P delta V. So delta V is 0. So work done is 0. Question number 32. A wheel of a bullock cart is rolling on a level road as shown in figure. If its linear speed is v in the direction shown, which of the following option is correct? Now for a rolling motion, we know that, right, suppose on this surface if the object is rolling, then in that case the speed of the center of mass is Vcm. The part which is at the top has a speed Vcm plus omega into r, and the part which is at the below or which is in contact has the speed Vcm minus omega r. So the same thing I have written here, right, for point P, which is at the top is V plus omega r, and the Q which is at the bottom has a speed V minus omega r. So clearly we can say that the speed of point P is greater than point Q, and at an instant this speed of point Q is 0. Question number 33. The mass of a planet is 1/10th that of the earth, and its diameter is half that of the earth. The acceleration due to gravity. Now the acceleration due to gravity, the very famous equation is gm by r square. Okay, now here the mass of the object is 1/10th, right, that is m by 10. If me is the mass of earth, then it is me by 10, and the diameter is half. Whenever diameter is half, the radius is also half, though radius is re by 2. The same thing I have put in this above equation. So here mass is m by 10 and the radius is r by 2. So r by 2 square. Now the 2 square is 4, so 4 will go up, and gm by r square is nothing but the acceleration due to gravity of earth. So it is 4/10 of the acceleration due to gravity. So it is 0.4 into g, and which is nearly equals to 3.92 meter per second square. Question number 34. In the following circuit, the equivalent capacitance between A and B So we have to find the equivalent capacitance between A and B. Now again it's a very easy question. You can see here it's a Wheatstone bridge. The equivalent circuit I have drawn here. Okay, so here this is point A, this is point B, and all the capacitors, right, which I have placed here, right, which are in the figure. Okay, so it's like a Wheatstone bridge, balanced Wheatstone bridge. So whenever you are dealing with balanced Wheatstone bridge, right, this part cannot be considered, right. So this we are not considering as a part of circuit. So the resultant circuit will be look like this one. So here two capacitors are in series. Again here two capacitors are in series and whole combination is in parallel. So for series combination it is 1 by C1 plus 1 by C2. So it is C by 2, the resultant will be C by 2. Again these two are in parallel. So C by 2, C by 2. So for parallel combination we add them. So C by 2 plus C by 2 is just C. So the resultant combination is C, and C is nothing but 2 microfarad because all are equal. So each I have taken as C. Question number 35. A thin spherical shell is charged by some source. The potential difference between the 2 points C and P. Now see here, C point is at the center. C point is at the center and P on the surface. Now for a thin shell, the potential is constant throughout the surface and at the center. So if you start from the center of this sphere to the surface, the potential is same. So that is the potential at point C and potential at point P is same, means the difference is 0. So the correct option is option number 4. Question number 36. The velocity time graph is given, right? We have to find which is the correct acceleration time graph. So the same graph I have drawn here. Let us try to understand that graph. So velocity time graph which is given here, that we are trying to analyze. So here the velocity is 0. Now velocity is increasing at a constant rate, means acceleration is constant and is positive. Then velocity is constant. Whenever velocity is constant, acceleration is 0. Again velocity is decreasing at a constant rate, means acceleration is uniform, it is constant and negative. So if you try to draw the same graph, here velocity is 0, so acceleration is 0. Again in the second part, here the acceleration is constant. Here you can see the acceleration is constant. So in this part the acceleration is constant, right. So this line is represented by this horizontal line because here it is A versus T graph, right. So same line for A versus T graph can be visualized like this because acceleration is constant. Now in the other part velocity is constant in the above graph. So acceleration is 0. So this part represent acceleration is 0. Now again the speed decreases at a uniform rate. So acceleration is negative. So here you can see the acceleration is negative and constant, right. So negative acceleration and constant. So for that part it is A and T. So it is represented like this. Okay, acceleration is constant and it is negative. So the correct graph or the correct option is option number 3. Question number 37. Again very easy question. The mass of the bob in a simple pendulum is increased to thrice of its original mass. Remember, in the equation of the time period of a simple pendulum there is no mass involved, means it is independent of mass. For length T is proportional to root L. So you can directly solve like this. Now what is given? Its length is made half. So T dash is equals to, you can see L by 2, means T dash is proportional to root L by root 2, right. But I have solved like this here. So L dash become L by 2. So T dash 2 pi under root L by 2g. So just I have taken out this root 2 out of this. So it is 2 pi under root L by g. It is T by root 2, but in the option is given x by 2, right. So to bring 2 here in the denominator, I am multiplying and dividing this term by root 2 and root 2. So root 2 into root 2 is 2. So here you can see it is root 2 into T by 2, right. So it is, this is the original. So the original becomes root 2 by 2 times, or the new time period becomes root 2 by 2 times of the original. Okay, so here if you compare this with the general expression which is given here, then x is equals to root 2. Question number 38. A 10 microfarad capacitor is connected to a 210 volt 50 hertz source, the peak current. So for peak current we can use this equation directly. I naught is equals to V naught by Xc, where Xc is the reactance of the capacitor. Now this V naught, right, V naught is nothing but V naught is root 2 Vrms. So I have written here root 2 Vrms, and Xc is 1 upon omega c. So if you put here 1 upon omega c, it will go up. So the peak current will be, peak means amplitude, highest current. So it is root 2. Now Vrms, which is already given whenever this kind of equation is given and frequency is given, the voltage given is the RMS value, right? So root 2 into 210, then omega is 2 pi into f. So it is 2 pi into f. F is 50 hertz is given, and the capacitance here C is also there, and the capacitance is 10 into 10 raised to minus 6. If you solve this, we will get 0.93 ampere. Question number 39. The following graph represent T-V curves of an ideal gas. So we have to identify that which graph shows highest pressure, or we have to arrange, right, the pressure into increasing or decreasing order. Means we have to verify which one of the given option is correct. Now from ideal gas equation, PV equals to nRT. Now all the slopes which are given are for T by V graph. So we can bring P here, so it is we can bring V here, so it becomes T by V. Now which terms are remaining, right? On bringing this V here, we are remaining with P by NR, because NR will go there, so it will be P by NR. Now N is constant, R is constant, so we can say P is directly proportional to the T by V slope. Means the slope highest for T by V has the highest pressure. Okay, so P1 has the highest pressure and P3 has the lowest pressure. So P1 is greater than P2 is greater than P3. So option number 4 is the correct option. Question number 40. An iron bar of length L has magnetic moment M, is bent at the middle. See, it is not cut, remember it is bent. Okay, most of the students confuse here, it is bent at the middle of its length such that the two arms makes an angle 60 with each other. The magnetic moment of the new magnet is, now the magnetic moment is, the formula is the pole strength into length. So in the initial case the length is L and the pole strength is QM. Now we are bending from the center such that it makes an angle 60, so it forms a right angle triangle, right? This two length, if I draw another line here, it makes an it also L by 2, because here angle given is 60 degree and these two are equal. So of course the third will be equal, right? So now we have our two poles which are separated by distance L by 2, right? So new magnetic moment will be QM, because pole strength remains same, but the separation between the two poles is now become L by 2. So it is QM into L by 2. Now QML is nothing but the original magnetic moment, so it becomes M by 2. Question number 41. The minimum energy required to launch a satellite of mass m from the surface of the earth of mass m and radius r in a circular orbit of altitude 2r. See, whenever altitude is given means the height is given from the surface of earth, which is 2r, but from the center of the earth it becomes r plus 2r is 3r. So we always consider small r, or a distance from the center of the earth. So work done is nothing but the change in the energy. Okay, so when the satellite goes at the higher altitude, what will be its total energy, and when it is on the surface, what is its total energy? The difference gives the work done. That is, the work done is equals to change in the energy, change in kinetic energy plus change in potential energy, right? So E final minus E initial, right? So for energy, we have equation minus GMM by 2R. This is the equation for the energy of a satellite. So here this is the equation for the total energy, right? So this is GMM by 2, and what is at the final position, its amplitude, its height from the center of the earth is 3r. So instead of small r, we are placing here 3r. Okay, so here it is 3r, so it becomes 6r. Okay, and initially it is lying on the surface of earth, so height from the surface of earth is just r, so it is GMM by r. So if now we can take common here GMM by r, GMM by r common, so and minus sign here, so it is minus, here 2 3s are 6, so 1 by 6, and minus minus plus, so plus 1. If you solve this, you will get work done is equals to 5 by 6 GMM by r. Question number 42. A parallel plate capacitor is charged by connecting it to a battery through a resistor. If I is the current in the circuit, then in the gap between the plates, see, when the current is flowing through the capacitor, we know that the conduction current is exactly equal to the displacement current. So displacement current of equal magnitude flows in the same direction as I. Okay, so both flow in the same direction, right? So option number 2 is the correct. Question number 43. The property which is not of an electromagnetic wave traveling in a free space. So it is a transverse wave, it is a correct, and energy density of electric field and magnetic field are equal, again correct. Speed of light is given by this equation, again correct. So this all three are correct. What about the fourth one? They originate from charge moving with uniform speed. This is incorrect. Electromagnetic waves are produced when charges are accelerate or they are oscillating, right? So this is incorrect, and in the question it is asked which is not correct or which is not property. So option number 4 is the correct option. Question number 44. A metallic bar of Young's modulus 0.5 into 10 raised to 11, that I can write as 5 into 10 raised to 10, and the coefficient of linear thermal expansion, that is alpha 10 raised to minus 5, length 1 meter is given, area of cross section 10 raised to minus 3, and the change in temperature is 100 degree Celsius, right? Now it is asked the compressive force developed, how much force is developed. Okay, so we know that Y is equals to F by A L by delta L. This is the equation for the Young's modulus. Now force is asked, so I can make F as a subject, so it becomes YA then delta L by L. Now how I will get delta L by L? So now for thermal expansion, we know that alpha is equals to delta L by L, where delta L is the change in the length and L is the original length, and delta T is the change in temperature. So if I make delta L by L as a subject, it becomes alpha delta T. So here it becomes alpha delta T that I have placed here. Young's modulus, it is 5 into 10 raised to 10, area is given 10 raised to minus 3, and the remaining term delta L by L that I have written as alpha delta T. Just putting all the datas here, we will get 50 into 10 raised to 3 Newton, which is the correct option. So option number 2. Question number 45. Choose the correct circuit which can achieve bridge balance. See, right now if you check all this one, there is no balance, they all are unbalanced. But suppose I want to achieve a balanced Wheatstone bridge by changing just the resistor, then how I can achieve? Okay, so if you check all other, for example here a diode is given, right, and it is in forward bias. So when the diode is in forward bias, right, it will provide a nearly zero resistance path, means this is not. So if you change this, it will, if you keep any value of this resistor, it doesn't matter because all the current will pass through this only. So you cannot achieve a balanced Wheatstone bridge. Okay, for balanced Wheatstone bridge, the ratio of this by this, it should be equal to ratio of this by this. Okay, for this it is not possible. For this fourth one, here it is positive, right, and here this a diode is connected such that its negative terminal is connected with the positive, means it is reverse biased. So reverse bias provide infinite resistance, so it has very high resistance again, so this cannot be used to achieve balanced Wheatstone bridge. Similarly here this is also connected in reverse bias, right, so this all three are cannot be used to achieve balanced bridge. So only one option we have, and that is option number 1, because here it is in forward bias, so it provides zero resistance. Now you can change this value and you can achieve the balanced Wheatstone bridge. Question number 46. A sheet is placed on a horizontal surface in front of a strong magnetic pole. Okay, so it is placed in front of a strong magnetic pole. So what will happen? If it is magnetic, then the magnet will attract. So if you want to keep it at the same position, you need to hold it, right? So the force will be needed if it is magnetic. But if it is non-magnetic, then the magnet will not apply any force, right? But here it is given hold the sheet there if it is non-magnetic, so it is wrong, right? So B is wrong. So then C, move the sheet away from the pole with uniform velocity if it is conducting, right? Now suppose if there is a magnet, right, it is north, and if you try to move it away or towards, it is given away. So if you move it away, then what will happen? The magnetic flux will change. The magnetic flux will change, then this due to the changing flux, this will AD currents will generate, and what will happen? A south pole will generate, and this sheet will attracted by the magnet. So to move it with the constant velocity, you need to apply an equal and opposite force such that it moves with the constant velocity, right? So this is the correct, that is a force is needed to move the sheet away from the pole with uniform velocity if it is conducting, right? Because it is conducting, that's why what will happen? The eddy currents will generate, and such that the sheet will be pulled towards the magnet. Okay, so a force will be needed to maintain a constant velocity. D, move the sheet away from the pole with uniform velocity if it is both non-conducting and non-polar. Move the sheet away. See, if it is non-conducting, then no force will be needed because no eddy currents will generate. Okay, so D is incorrect and B is also incorrect. So correct option are A and C. Question number 47. If the plates of a parallel plate capacitor connected to a battery are moved close to each other, see, what is the capacitance? Equation for the capacitance? Epsilon naught A by D. Means you are moving two plates closer. So when you move them closer, the capacitance will increase because distance decreases, right? And now equation for the capacitance, this is just a general equation, Q by V. So when the capacitance increases, right, the ratio Q by V also increases. Okay, so as Q increases, V will also increase, right? So the charge stored in it increases. Yes, it is correct one. The energy stored in it decreases. Now what is the equation for the energy? It is half CV square, and another equation is half Q into V. So Q increases, V increases. It means the multiplication Q into V, that is the energy, also increases, but here it is given decreases. So this is incorrect. Its capacitance increases. Yes, it increases, that we have already seen here, right? I have given this mark A, C, E, means this represent the given statement. D, the ratio of the charge to its potential remains same. No, right? Q and V both increases because C is increasing, right? It means D option is incorrect. Option E, the product of charge and voltage increases. Yes, Q into V increases because energy also increases, and also Q and V both are increasing, so their product will also increase, hence E is correct. So which options are correct? A correct, C correct, and E. So A, C, E are the correct options. Question number 48. two heaters A and B have power rating 1 kilowatt and 2 kilowatt, right? Those two are first connected in series. So for series combination, right, we have 1 upon P1 plus 1 upon P2 for powers. Okay, if you want equivalent power in series combination. So the resultant power, if you place in this equation, you will get 2 by 3 kilowatt. And for parallel combination, you just add them, P1 plus P2. So now becomes 1 plus 2, it becomes 3 kilowatt. Now it is asked the ratio, right? Then the ratio power output for these two cases. So first it was series. So series to parallel, the ratio will be 2 by 9. So option number 2 is correct. Question number 49. A small telescope has an objective of focal length 140 and eyepiece of focal length 5 cm. So magnifying power is asked, and very simple, for telescope it is FO by FE. So FO is 140 and FE is 5. See, remember, sometimes the students get confused. Then what is the equation, FE by FO or FO by FE? See, every time the magnification power of telescope will be very greater than 1. It means the numerator will be larger. So it is always FO by FE, because in telescope FO is very greater than FE. So it is 140 by 5, it is 28. So option number 2. Question number 50. A force defined by F is equals to alpha t square plus beta t x on a particle at a given time, the factor which is dimensionless if alpha and beta are constant. So I have used easy method, just I have placed all the units, and we know from the principle of homogeneity, we know that all the terms here has same dimension as of force. Means here on the LHS side we have force. So alpha into t square has same dimension as that of force. Similarly, beta into t has same dimensions of that of force. So here F is the units of F are kg meter per second square. Alpha as it is, here it is t. So it is unit of time is second. So it is second square. Here it is beta, and unit of time is second. Now I am just comparing these two terms. First I am comparing this alpha s square with kg meter per second square. So alpha will be kg meter by s raised to 4, second raised to 4. Similarly, for I am comparing this beta t or beta into s with this term. So again beta into s is equals to kg meter per second square. So beta becomes kgm by second cube. Now I am just taking the ratio alpha by beta, because I don't know which one is the correct one. So I am taking ratio. So alpha by beta you will get 1 by s, because this here fourth power and it is have 3 power. So 1 by s. Now to remove this s completely, you need here one more second here, right? So if I multiply this term by t, then second will get cancelled. So the ratio become dimensionless, means alpha t by beta is dimensionless. So option 2 is correct.